Hello, meet Artikosa, the face of mathematics. Myself, I always believe in understanding, and that's what says me most of the time. So, if you wanna join me in this journey, you all welcome. My goal has been assisting other students and making things much simpler. So, last time I did with you the interaction effect and tried to explain what's going on with which formula to use. So now we're about to do an exercise that will determine how far you understand. If you haven't watched the video yet, watch it because you're gonna miss a lot. Let's begin. A customer product company relies on the direct mail marketing pieces as a major component of its advertising campaign. The company has 3 different designs for a new brochure and want to evaluate their effectiveness. As there are substantial differences in the cost between the 3 customers in 4 different provinces of the country. Since there are known provincial differences in the customer base, provinces are considered as blocks. The table below represents the mailing means which had 2 replications per cell. So we're having the designs as treatment and province as block. So we know that we are given the means per each cell and which had 2 replication. So we're required to analyze the data and draw conclusion. We are given the triple summation of yijk squared, which is 3,519,720. Since we are given the means per each cell, what will come in mind is for you to use the formulas that have to go with that to get directly. You can use the other formulas, but they will be dry. So first thing first, what we are going to be looking for is the overall sum of these means per each cell, which will help us to calculate SSTO, since we know it's given by this formula and we already have this. So this is just the sum of everything, which we can replace it by this value as you can see here. So we get our SSTO as 316,477.333. And for SS model, we'll need the overall sum of the mean of each cell square, which is 410 square plus 375 square plus 230 square until you add 305 square. So on this part, so you'll get 1,702,982 minus this part here. So SS model is given by 202,721.333. We can also calculate SSE, which is nothing but SSTO minus SS model, which is 113,756. For SS treatment, you use this formula where this will be given by the sum of means of each cell per treatment. You have to add these values. For the first treatment, you square. You also do the same for the second treatment, you square. And so with the last, you square. So this part, as you can see, it remains the same as it is. So we get our SS treatment as 110,608.333. Now moving to SS block. This is the formula. Here you will need the sum of the means of each cell on that particular block. We need, for the first block we square, for the second block we square, for the third block we square, and for the fourth block we square. So we find the sum of square block as 66,518.667. So now that we have SS treatment and SS block, we can find SS interaction, which is given by SS model minus SS treatment minus SS block. So we have 25,594.3333. We can now go to the ANOVA. So this is our summary table. So we'll have to test for the interaction first. Since our F tabulated with the degrees of freedom of 6 and 12 is bigger than the F calculated, we fail to reject HO and conclude that there is no interaction at 5% level of significance. Since we fail to reject HO and conclude there is no interaction, we'll have to test for the main effect. We have to test for the effect of treatment, if the treatment means differ or they are the same. Since our F tabulated with the degrees of freedom 2 and 12 at 5% is less than the F calculated, we reject HO and conclude that there is a difference among the means of treatment at 5% level of significance. Lastly, we'll have to test for blocking if it was effective. Since F tabulated at 5% of degrees of freedom 3 and 12 is bigger than F calculated, we'll fail to reject HO and conclude that blocking was not effective at 5% level of significance. I thank you. Enjoy.